Hi, so what I'm going to do today is I'm going to do a little bit of vector geometry. This brings me to the last part of my series on two-dimensional vectors. Alright, so I'm going to look at a few examination examples, some questions, and hopefully if you go through them with me, you can have a better idea. So let me bring the diagram here. They are saying that Q is a midpoint of this line OC here. Alright, so whatever OQ is, the distance Q to C has to be the same. So maybe we can just do that. So whatever this distance is, it has to be the same as that distance. And then they are saying also that OA, which is this here, and AB and BP, they are all equal. But what they are also telling us is they're telling us that the whole distance from here all the way up to there is represented by the vector 6p. All right, so that means then that this one here, this one here, and this one here, if you divide 3 by 6, it has to be 2p here, 2p between AB, and 2p between BP. So now they are asking us to find OB. So you can see from the diagram here that OB has to be nothing but 2p plus 2p, which is 4p. Right, then they ask us to find BC. Now, when you go from B to C, it's like you are going in the direction of BO. So BC is BO, okay, all the way plus OC. Now we know that BO, you are going against, all right, so it's minus 4p, and OC, they're telling us that O all the way up to C has to be, remember, we have got OQ is R, so OC will also be the whole one from here all the way up to here has to be 2R. That's that R plus another R. Okay, so we need to find then plus 2R. So let me just bring it here. So this is 2R here. All right, so essentially that is what I expect to get as an answer there. Okay, so let me just bring in my answers that I already worked out. Okay, so I realize then it's going to be BO is minus 4p plus 2R. A third one, they want us to find the distance from A to Q. So when you go from A to Q, is you go AO plus OQ. So when you go AO, you are going against minus, you get 2p, so that's minus 2p plus R. Okay, so something very interesting also here is that you can see that this particular vector here, all right, and also this particular vector here, if you look at them nicely, you can see that they are multiples of each other, all right? They are multiples of each other. So if you take AO, 2 of AQ rather, you realize that you are going to get BC. All right, so that is what you are going to get when you look at these two particular vectors here. Okay, so BC is twice as long as AQ. Right, so there's a question in that respect. They're asking us, what can you see from deducing those two? You can see obviously that they are multiples of each other. All right. So let me bring in question 2 here. So they are saying in this particular diagram here that OA, the distance from O to A, is exactly 2/3 of whatever the distance is from O to P. And the distance O to Q, all right, OB represents 3/4 of that particular distance. So that is going to be 2/3, and this one is going to be 3/4. Right? So you're supposed to find in terms of P and Q. So you're going to obviously, you can't bold P and Q, you're going to write with a line underneath. Right, so you're going to find A all the way up to Q. But remember now that this is very important so that you don't get confused. This particular distance here represents 1/4 of Q. Okay, so 1/4 of Q. So the whole thing here represents nothing but Q. Okay, so if you are going from A all the way up to Q, all right, maybe you can first write it down. You can see that you are going against 2/3 P plus that whole distance of Q. Okay, so what you can also do, if you don't want to go straight up, you can say AQ is the same as AO, all right, plus OQ. That's what you can as well do, all right, and then that should definitely bring you to your correct answer. But you must leave your answer in terms of P and in terms of Q. Right, now they are asking us to find BP. That is obviously the distance from B all the way up there. So what you can see is that from B to P, you can say it's BO, okay, plus OP. So we know what OP is, all right? OP, or first of all, let's take BO. BO, since we have from BO, we have it is minus, because we are going against that, minus 3/4 of Q, all right, because you are moving basically from B to O, so you're going against that, all right, and then we're going to add that whole OP, all right, so that whole OP again, it has to be represented by nothing but P, so this is 1/3 of P, that is from A to P, so the whole thing here again is just going to be P, all right, so that is what you are going to add, and this is what I expect to get as an answer. Okay, so you would realize that I have minus 3/4 Q plus P, which is represented by that whole distance up there. Now they're telling us something else. They're saying that BT, which is this little distance from here to here, all right, it is 1/3 of what BP is. So we know what BP is, all right? So let us just work that out. So 1/3 of BP, all right? So we know what our BP is. Our BP is nothing else but this whole vector here, okay? So if they are saying then that that is 1/3 of that, so we're going to take 1/3 of minus 3/4 of Q, okay, plus P, right? So when you clean this up, this is going to give you nothing but BT, okay? Let me just make sure that you get that, all right? So that's going to give you BT, right? So when you multiply this little bit of algebra stuff here, so you're going to get negative, now you're going to get negative 3/12, right? So negative 3/12 Q plus 1/3 P. Now, so I'll tell you to write it like this so that you can see the vectors clearly. Right, and also maybe what you can also do is you can also simplify this negative 3/12. So it can therefore become negative 1/4 of Q, okay, and then plus 1/3, all right, of P. So you can also get something like that. So that is what I expect to get. Right. So now that I have that BT, all right, so we are supposed to find QT. All right. So we are supposed to find QT. And for you to find from Q to T is nothing else but a very interesting direction that you're going to take. So when you are going from Q to T, that is going to, you're going to go QB plus BT. All right, so the reason why I had to find BT here, all right, was for me to be able to definitely find that particular answer. And also what you need to realize is you're going here against, all right, so you're going to expect this answer to be minus 1/4 of Q. All right, so you would see that I have done something similar for my particular solution. So I'm just going to bring them up, and I know it's kind of messy here, but if I clean this all up, you will definitely get the idea as to how I got to my answer. All right, so the first thing I did here is I said, what is Q2 actually equal to? All right, so Q2, as I was saying, Q to T was giving you the distance from Q to B and plus that little bit of BT. And then obviously I will write them in, okay, and then I will clean this up. So now I have that negative 1/4 Q, which is this particular distance here, plus a third of that. All right, so if you clean up and you multiply out, you're obviously going to end up eventually with negative a half Q plus 1/3 of P. So just make sure again that you get that particular answer correct. But take your time, be very careful. There's a lot of algebra involved so that you do not end up making a mistake. All right? Right, so something that I want to bring up is displacement vectors that we can write in terms of position vectors. Now, let me just, because in my previous videos I did explain what position vectors are. These are vectors that simply start from the origin, from O, like OC is a position vector. OD is a position vector, okay? But DO is not a position vector. All right, so this is not a position vector. In order for you to make this a position vector, then you are going to have OD. All right, so then you're going to have a minus in front. Okay, so you're going to have a minus OD in order for it to be a position vector. So in this particular case, it is not a position vector if it is given as DO. It has to be starting from O, all right, and then the next one is obviously your D. So OD is a position vector. So something interesting happens when you want to write DO, for example, as a position vector. You swap them around, and then you have a negative now. Okay, so position vectors are always starting from the origin. They always have that O or that zero, but not zero, but O for the origin. Right, so let me bring in a diagram here. So when you look at this particular diagram, and I want you to find C to D. Right, so when you go from C to D, it's the same as going CO plus OD, and I wrote it here. But you realize, as I said, that CO is not a position vector, but we know that OD is a position vector. So we're going to go ahead and write CO as OC with a minus in front, and now it is a position vector. But if we bring it in nice clearly, you can put the positive one in front and the negative one here. So in a nutshell, you should realize something very interesting, that whenever you write something like EF, all right, or BC as a position vector, all right, so you have got, for example, BC, and you're supposed to write it as a position vector. So you take, and this is very important, you take the second point, which is the C. So we're going to say OC, all right, then I'm going to say that equals to, very important, minus the first point. Okay, so what I refer here by the first point is, I'm talking here about that B there, so it's going to be minus OB. And whatever you get there, you are going to get exactly that particular vector there. So let me just look at the diagram again and just see if it definitely works out. All right, so let us just see what is CD in terms of the diagram. So CD is equal to, all right, and now here you must be very careful because you have to go and count. So it's 2 positive and 2 negative. Okay, so I'm going to have 2 positive and minus 2. So that is the column vector from C to D. But we also know that CD is the same as saying OD minus OC. And here's the thing about OD. OD will be 3, 1, that is OD. Okay, and in order for you to find that OD, you'll just have to go here. So that's 1, 2, 3, and 1 up. Okay, and then we subtract that minus OC, and OC is 1 across, and then also you go 3 up. So it's 1 across and 1, 2, 3 up. So it's going to be something like that. Right, so when you subtract, obviously you're going to end up with 2 over negative 2, which is exactly the vector that we were looking for. All right, so that is one of the things that you should remember, and it is not fairly easy as long as you remember this very important note that I have here at the bottom, that when you want to find a displacement vector, whether it's A, B, C, D, or whatever, you take the second position and you subtract from the first position. Okay, first point is being subtracted from the second point. So I'm going to do a few examples just to see if you have kept on what I'm saying. Right, so we are supposed to write the following displacement vectors in terms of position vectors. So again, as I said, the second point minus the first point. So it's OB minus OA. Okay, so when we do this one here, EF, the second point being OF minus OE. All right, so your initial one is A, your terminal one is B, you're starting with E, you're ending with F. So now you're going to have OF and then minus OE. A third one, again, if you can do this one, it's OH minus OG, vector OH minus vector OG. All right, so a last one here, you have got vector KL, so that can be written as vector OL minus vector OK. All right, so this is how you write them in terms of position vectors. All right, so this is very important. You must never forget that. You take the second point and minus the first point of the position vector. All right, so there must be that O in front of them. Now, this is going to help us quite a lot with the next problem that I have brought up for question 4. So let's look at question 4. They are saying, give the vector for each of the following. Now, these are coordinates. Now, remember, this is very important that you understand. If you have your Cartesian coordinate system, okay, so that's your x-axis here, and that's the y-axis here. So when you are looking for the point 2, negative 7, so the point 2, suppose it is here, and the point negative 7, suppose it's here. All right, so that particular point, all right, has to be all the way down here. So this here is the point, all right? That's the point 2, negative 7. So here is my origin. So when I am finding the position vector, it has to start, remember, it has to start from the origin. So if I look at that particular vector there, all right, so it has to be, you can rewrite it as OA, vector OA, because it starts from the origin, is nothing but, when you write it as a column vector, 2 cross and negative 7 down. So that's what you can do with that particular question. All right, so you're going to change them into column vectors. All right, position vectors. That is what you will be doing, and from there on we can answer the questions that are following. All right, so let me bring the first question up in terms of what we have here. So they are saying here we are supposed to, remember I have done that, all right, write each or give each in the following the vector for each of the following. So again, here you have got OC now is equal to 1, negative 3. All right, so you expect that OC to be all the way, let's suppose 1, negative 3 is going to be also somewhere here. All right, so it could be a point that is all the way also in this quadrant, and that is where our point C will be. All right, so as a vector, it will be definitely something like that. All right, so that just gives you an idea that you can also rewrite coordinates in vector form, all right, obviously by applying the concept of position vectors. Right, so then what I also like to do, because remember we are not totally finished with this particular question, all right, we are supposed to find the vector from A all the way up to C. That is why it was necessary for us to write OA and OC as position vectors. Does that make sense? All right, so we are supposed to find AC. All right, so when we find AC, it is going to be the second point, which is OC, minus the first point there, which is OA. Right, so now what you do is you just punch in your vectors now, your column vectors. So you have 1, -3, minus 2, -7. And then you have the answer. All right, so you can leave your answer as a vector, or you can just give it with base vectors, minus I plus 4j, all right, minus 1I plus 4j. But we are fine with -1, 4 for now. All right, so now we have got C to D. All right, so if you've been paying attention, C is going to be 1, -3, vector OC. All right, and then D is going to be OD equals to 2, -7. Then you are supposed to find C to D, and to find C to D, you take OD, the second point, minus the first point. All right, position vectors. Right, so from here on, you just take 2, -7 minus 1, -3. All right, so the answer here is 1, -4. Or you can write it as a base vector as I minus 4j. So I hope it helped you here, right? Because we're going to use this knowledge to answer. There's one more word problem where you need to apply this. So let's look at this question here. So I have got vector AB, which is equal to 7 over 1. BC is 2, -5. So they are saying express A to C as a column vector. All right. So A to C is nothing but AB plus BC. All right. Your starting point, your ending point. Okay. Terminal and point, and your initial point and your ending point. Your initial point is A. Your ending point is C, okay, the terminal point that we're referring to. All right, so you're just going to have to add them together, and then you get 9, -4. Right, here is now another question. They say point D is -2, 1. Point E is H, 6. Right, so we are supposed to find DE as a column vector. Now remember from our previous work, the way you find DE as a column vector, okay, and I hope you paid attention, you're going to say DE, all right, it's going to equal to OE, second point, all right, OE, which can be written then as H6, that will be what O is, minus OD, and OD can be written then as nothing but -2, 1. Okay, so that is basically what I expect you to be able to do. All right, let me bring in my correct or typed solutions to this particular problem. What I also did is I also bring in a diagram so you can get an idea. All right, so let me make a small sketch. So this is what I did here. So I did a small sketch now. All right, so I have now more or less, I know where point D is. Okay, point D is -2, 1, so somewhere here. And point E, well, the H value is X, it's positive, so it can be anywhere here, but I know my E is 6. All right, so the idea is for us to find D to E. Right, now when you want to find D to E using this diagram, okay, so if you want to find D to E as a column vector, right, remember DE, you're going to have, and this is now very important, all right, so we're going to need to know what is the distance from here. Let us first take the X, all right, all the way from here all the way to there. So this particular distance here is nothing but these 2 units here, all right, absolute value of that, and this little h here that you have, this distance of h. So that x will be nothing but h plus 2, okay? And now to find our y, exchanging y, all right, it has to be nothing but 6 minus 1, which is going to be 5. That's how we are supposed to do it. If you are using a diagram, just for you to be able to quickly remember. But let's bring in, obviously, our position vectors, all right, that I have talked about a little bit in a while. So our position vectors is that point D is OD, which is equal to negative 2, 1, and point E, which is h, comma 6, is now written as OE, all right, h6. So from here, you can apply now your concept, all right? The concept therefore becomes you find D to E, which is DO plus OE. If you look at what we need to do, all right? So D to O plus OE. But that is now if you were to apply also a diagram, okay? And this is the origin here, and you need to be able to calculate that little distance then. So let me just bring in that line. So it's going to be O to E, DO, all the way here, all the way up to OE. All right. So, but DO is not a position vector. Can you see that? All right. So we need to then change it to that. But if you can also remember what I said, that little hint that I gave you, you should be able to definitely get that particular answer, which is identical to what I did here when I was calculating the vertical distance and also the horizontal distance, which is h plus 2 more. And the vertical distance is that 6 minus 1, which we can actually determine. Right, so now here they are giving us another set of information. They are saying DE is parallel to AB. So let me bring DE back and let me also bring AB. So these two are parallel. So therefore, some scalar quantity multiplied by that 7, 1 should equal to this. So from here, you just multiply, okay, 7 times k equals to h plus 2, all right? You equate them. And then the second one is k times 1 here equals to 5. So now we know what k is. K is equal to 5. So what I'll do is I'll take that 5 and I substitute it here, all right? The objective is to find the value of h. All right, so 7 times 5 is 35. And then obviously h should give you 33 as an answer. Right, now you have got a second or a third part to this question. They say that the absolute value of D, E, or the modulus rather, of DE is equal to AB, the modulus, the magnitude of AB. Right, so now if I bring in my AB as well, so when you are finding the magnitude of DE, right, it's nothing but Pythagoras that we are using. Okay, so we have got that h plus 2 all squared plus 5 squared. It should equal to 7 squared plus 1 squared. But now if the square root is equal to some square root, you can actually drop them, because what you're actually doing in a nutshell is you are taking squares both sides. When you take the square there, and also when you take the square here, all right, so that's going to leave you only with the stuff that is underneath the square root. Okay, right, so from here I have written that particular one here in blue because you need to multiply that particular one out. Okay, it gives you h squared plus 2h plus 2h plus 4. All right, so then that equals to that 25, which is equal to 50 here. Now you clean this up, you eventually end up with a quadratic equation, which is h squared plus 4h minus 21 equals to 0. Now this particular equation here will definitely factorize, giving you h plus 7, h minus 3 as the factors there. So equate everyone to 0. That should give you the answer. One answer is h is negative 7, and the other answer is h is equal to 3. Right, so let me bring in another question here. So you have to be a bit careful with the diagram, make sure that you understand everything. They're saying that A to C is parallel to OB. Okay, you can see these little arrows are indicating that. And then they're also telling you that AX is 1/4 of AB. All right, and then they are saying AO is equal to vector A, as you can see there, and OB is equal to B. Okay, OB is equal to B, all right, and AC is equal to KB. Right, so now they are saying, right, in terms of A and B, express AB, vector AB, all the way from A up to B. So when you go from A to B, that's the same as AO plus OB. And we know what AO is. AO would be minus A because we are going against this, all right, plus that B there, which you can also rewrite as B minus A. The second one they want us to express is AX. So from AX again is AO plus OX, all right. So AO, which we know is minus A, all right. Then we need to find also OX. But what we know is, we also know that AX, all right, because we don't have OX, but we know that AX from the information here is 1/4 of whatever AB is. Now we know what AB is. AB was nothing but B minus A, or minus A plus B. So you just multiply that by a quarter, okay? All right. So that should give you the answer there for AX. Then they are saying we are supposed now to use BC. So BC is like you're going BA plus AC. For you to go from B to C, you go BA plus AC. Now we know what AB is. So BA has to be the reverse of that, minus that. And obviously AC is equal to KB. They are saying you're supposed to write this in terms of A, B, and K. So when you clean this up, you multiply out and so on, and you collect the like terms, the like term being this KB with that minus B, and a negative times a negative give you positive. So what I like to do is like to take the coefficient here. The coefficient of this one is -1, and I rewrite it like that. So this is how this particular one is done. Okay. So if you are a little bit worried or confused, there is a coefficient here of 1. Okay, and we take out those coefficients then. All right, so let's bring that diagram back in and let's look at what they're asking us here. They're saying OX is parallel to BC. All right, so we need to find the value of K. Right, now in order for us to find the value of K, OX is nothing but OA plus AX. All right, now I know what AX is. So if I can quickly work out my AX here, if I work it out, I will eventually end up with something like this. So that is the value of AX. Okay? Right. So now I also know from the diagram, you can also see what OA is. OA is A plus that little bit there. So when you clean this up, you're eventually going to get 1A minus 1/4 A is nothing but 3/4 A. And then obviously the other one remains 1/4 B. So this is how you find OX. So but they are not saying that it's parallel to BC. All right. So when they're parallel to one another, it means that their coefficients are in proportion. Okay. So if their coefficients are in proportion, we should be able then to find our missing K. And the way we do that, all right, is we, let me bring in OX and let me bring in BC when we say they are parallel. So I take the coefficients of A, divide by the other coefficient of A, and let it equal to the coefficient B over the other coefficient of B. So the coefficient of A here is 3/4 over this one here, and it's equal to 1/4 over the coefficient here, which is K minus 1. So the only thing left for you to do is to solve this equation. You can do cross multiplication, you eventually end up with that. So what I like to do here is that once I realize that I have got denominators that are the same, I can actually cancel those denominators and only work with the numerators there. As you can see what I've done there. But whatever the method, you should still definitely arrive at K to equal to 4/3, or 1 1/3.